representation of psi. I told you we have two representation. One is position representation, that is r coordinates, and another is momentum representation. That is as a function of momentum p. That is, the wave function will be a function of r here, and the wave function will be a function of p in the momentum representation. And in position representation, we know the operator x cap equal to x and p x cap equal to minus I h cross dou by dou x. And the same operators in momentum representation will be p cap equal to p and x cap is equal to I h cross dou by dou p. Here you can see the commutator operator, that is x px will be equal to I h cross, and in the case of momentum representation also the commutator x px will be equal to I h cross. That is, commutator operator is independent of representation. Okay, now my question is how we can find out momentum representation if position representation is given, and if momentum representation is given, then how we can find the position representation. So this is the question. What is the equation? What equation connect these two representations? So here what we want to do, we want to change the basis. That is, from position representation to momentum representation and vice versa. Okay, that is what we want to do. Now, how we can interchange the basis? The mathematical tool is integral transform. By integral transform, we can change the basis. And what is the integral transform? I tell you one general expression, that is f of s is equal to integral a to b f of x k dx. This is the general expression for integral transform, where k is called kernel. So the kernel will change from x coordinate to s coordinate. So kernel will be a combination of x coordinate and s coordinate. So the kernel determine the different kind of integral transform. So based on the kernel, we can classify three type of integral transforms here. So first one is a equal to 0 and b equal to infinity. The limit is from 0 to infinity, and kernel is equal to e raised to minus sx. So here f of s is equal to integral 0 to infinity f of x e raised to minus sx dx. This is called Laplace transform. And the next one is a equal to minus infinity and b equal to plus infinity. And kernel is equal to e raised to minus isx. That is, f of s is equal to integral minus infinity to infinity f of x e raised to minus isx dx. This one is called Fourier transform. Okay, and another one is a equal to 0 and b equal to plus infinity, and kernel is equal to sin sx or cos sx. So we will get f of s is equal to integral 0 to infinity f of x sin sx dx, and another combination is f of s is equal to integral 0 to infinity f of x cos sx dx. The first one is called sine transform and the second one is called the cosine transform, that is Fourier sine and cosine transform. Okay, so please be careful about this limit and the kernel. Okay, limit and kernel. The limit and kernel determine the type of integral transform. Okay, so for our case, here I am adding one more transform, that is a equal to minus infinity and b equal to plus infinity, and kernel is equal to, here this e raised to minus isx. Now I am going to take e raised to isx, that is f of s is equal to integral minus infinity to infinity f of x e raised to isx dx. So this one is called inverse Fourier transform. Here our aim is to transform position basis to momentum basis and the momentum basis to position basis. For that purpose we are going to use this Fourier transform. So we are going to use these equations. Okay. Now the first one, that is we have a wave function in terms of x. Now we have to transform it into a wave function in terms of p. Then we have to use this equation, that is psi of p is equal to 1 by root 2 pi h cross integral minus infinity to infinity psi of x e raised to minus I kx dx. See, this one is Fourier transform of psi of x. Okay, second one, if in a question they given the wave function in terms of momentum, then how we can find out it in terms of position coordinates, that is psi of x is equal to 1 by root 2 pi h cross integral minus infinity to infinity psi of p e raised to I kx. See, the sign is changed, right? Earlier it is minus, now it is plus. Okay, into dk. This is nothing but Fourier inverse transform. Inverse transform of psi of p. By using these two equations, we can change the position basis to momentum basis and the momentum basis to position basis. Okay. Example problem. See, a wave function is given in terms of x. Okay, and the question is to find out that wave function in terms of p. So how we can do? We can use the Fourier transform. But before doing that, we have to do the normalization. Why? Because it is about a free particle. So this wave function should represent the particle. Particle is a physical reality, right? So the wave function should represent the physical reality of the free particle. Therefore, we have to do the normalization first. So what is this condition of psi of x, that is equal to a? For mod less than or equal to a, that means x value is between minus a and the plus a. That is the meaning of modulus of x less than or equal to a. So this is less than or equal to, okay, and this is equal to 0 otherwise. So don't be confused. This is the x-axis. Okay. So this is x equal to 0. And we know there is two a values. One is minus a value here. And there is a plus a value here. Right. And the modulus of x equal to a means in the negative x-axis x equal to minus a, and in the positive x-axis x equal to plus a. Okay, this is the meaning of mod function. That is, in the positive x-axis it will have positive value, and in the negative x-axis it will have a negative value. Okay, so this is the condition, given condition. So first we have to do the normalization. What is normalization? Integral minus infinity to infinity mod psi square dx should be equal to 1. Here this limit is only from minus a to a, and the wave function is a, so molar square will be a square dx, that is equal to a square into x, and limit is minus a to a, that is we get a square into upper limit is a minus lower limit is minus a, that is plus a. That is we got 2a into a square is equal to 1. Therefore, we can find out a square, that is equal to 1 by 2a, and therefore a is equal to 1 by root 2a. So now we got the normalized wave function. Okay, that is the normalized wave function is a is equal to 1 by root a. Now we have to substitute this value in this equation. So we get a is equal to 1 by root a. Here in this question, what we want to find out? We want to find out psi of p. So what we have to do? We have to take Fourier transform of psi of x. That is, psi of p is equal to 1 by root 2 pi h cross integral minus infinity to plus infinity psi of x e raised to minus ikx dx. This is the general equation. So we have to substitute all these values in this equation and just do the integration. You will get psi of p. That is, psi of p is equal to 1 by root 2 pi h cross integral. Here the limit is only from minus a to a, and the psi of x we got it is equal to 1 by root 2a into e raised to minus ikx dx. That is equal to, here we can take this constant outside the integral, that is 1 by root 2 pi h cross into 1 by root 2a integral minus a to a e raised to minus ikx dx. That is, psi of p is equal to 1 by 2 into root pi h cross a into, now we can take the integral of this function, that is e raised to minus ikx by minus ik, and limits are minus a to a. That is equal to, I am slightly rearranging this equation, that is 1 by k root pi h cross a into, now I can substitute for a limit, upper limit, that is e raised to minus ika minus e raised to plus ika by minus 2i. So when this minus I is taken in the numerator, it will be equal to 1 by k root pi h cross a into e raised to ika minus e raised to minus ika by 2i. What is this value? This is nothing but sine ka. So finally we got the answer, that is psi of p is equal to 1 by k into root pi h cross a into sine ka. Another example problem. A wave function is given, psi of x is equal to 1 by root L e raised to minus ikx, and the modulus of x is less than L. That is this wave function for modulus of x less than or equal to L. The question is to find psi of p. So the question is to find out psi of p. So how we can find out psi of p? Find the Fourier transform of psi of x, that is psi of p is equal to 1 by root 2 pi h cross integral. Here limit is from minus L to plus L, and the f of x is here psi of x into e raised to kernel, that is minus I k x into dx, right? Now we have to substitute for this psi of x, that is psi of p is equal to 1 by root 2 pi h cross integral minus L to L f of psi of x is equal to 1 by root L e raised to minus kx into e raised to minus kx dx, that is equal to 1 by root 2 pi h cross, and we can take 1 by root 2L outside, that is root L integral minus L2 plus L e raised to minus ikx into e raised to minus ikx, that is minus 2ikx into dx, that is psi of p is equal to 1 by root 2 pi h cross L into integral of this term is e raised to minus 2ikx by minus 2ik, and limits are minus L to L, that is equal to 1 by root 2 pi h cross L into, now we have to substitute this limit, upper limit and lower limit, so e raised to minus 2ikl minus e raised to 2ikl by 2ik. So here we can take this k this side, so the remaining we get psi of p is equal to 1 by k root 2 pi h cross L into, sorry, here I missed one minus sign also, so this will become, so this term will become e raised to 2ikl minus e raised to minus 2ikl by 2I. We know this term, what is this? This is nothing but sine 2kl. So we will get psi of p is equal to 1 by k into root 2 pi h cross L into sine 2kl. Another example problem, psi of x is equal to a e raised to minus mu mod x. Find psi of p. Here this one is not a normalized. Here this one is not a normalized wave function, right? Because there is a constant. So first we have to evaluate what is this value of a. That is, we have to normalize this wave function. How we can normalize? That is integral minus infinity to plus infinity mod psi square dx should be equal to 1. That is minus infinity to plus infinity mod psi square, that is a square e raised to minus 2 mu mod x dx should be equal to 1, right? And here there is a mod function, and this is an integral from minus infinity to plus infinity. So we can separate it into two regions, that is, one is from minus infinity to 0. Why? Because this mod x have different value in different region. So in the region that is minus infinity to 0, a square e raised to, here in the negative region, I told you in the negative region the mod x will have a negative value, that is this x will be negative x, that is plus 2 mu x dx plus 0 to plus infinity a square. Here in this region, that is in the positive region, the x will have positive value, that is e raised to minus 2 mu x dx. Now we have to evaluate these integrals, that is we can take this a square outside and integral of e raised to plus 2 mu x, that is plus 2 mu x by plus 2 mu, and limit is minus infinity to 0 plus integral of second time is a square is a constant into integral of minus 2 mu x by minus 2 mu. Limits are 0 to infinity. Now we have to substitute these values, that is a square into upper limit of this one is 0 e raised to 0, that is 1, minus lower limit is e raised to minus infinity, that is 0 by 2 mu plus second time, that is a square into upper limit, that is infinity, that is e raised to minus infinity is 0 minus lower limit, that is e raised to 0 is 1 divided by minus 2 mu. That is we got a square by 2 mu plus a square by 2 mu, and that is equal to 1. Right, that is the condition for normalization. Therefore, we got 2a square by 2 mu equal to 1. Therefore, a is equal to root mu. Okay, so the normalization constant is root mu. Actually, you don't want to do all these steps. If it is a mod x, I tell you a trick. See, this is the given wave function, that is psi of x equal to a e raised to minus mu mod x. And after normalization, we got a is equal to root mu. See, what is this root mu? Root mu is coefficient of mod x. That is, if mod x is there, then normalization constant will be root of coefficient of modulus of x. That is, here it is root mu. Don't be bothered about minus sign or plus sign. Okay, anyway, this will be the answer. Okay, so just take the root of coefficient of mod x, you will get the normalization constant. So now we got the normalized wave function. That is psi of x is equal to root mu e raised to minus mu mod x. Now the question is to find out psi of p, right? So what do you have to do? You have to take Fourier transform of psi of x. What is this Fourier transform of psi of x? That is psi of p is equal to 1 by, definition is root 2 pi h cross integral from minus infinity to infinity f of x. Here f of x is psi of x e raised to minus I kx dx. So we can substitute for psi of x and we can evaluate this integral, that is psi of p is equal to 1 by root 2 pi h cross integral minus infinity to infinity. Psi of x is, that is, this is the normalized wave function, root mu e raised to minus mu mod x into e raised to minus I kx dx. Here you see, this is a mod x function. This mod x function have different values in the negative region and the positive region. So we have to separate this integral. That is, we have to separate into two integral. One is from minus infinity to 0 and other is from 0 to plus infinity. So in the negative x-axis, this mod x will have negative x value, and the positive x region, the mod x will have positive x value. Okay, that is why we are separating this integral. That is psi of p is equal to 1 by root 2 pi h cross integral minus infinity to infinity root mu, and in the negative x-axis, x will have negative value, that is e raised to mu x into e raised to minus ikx dx, plus the second time, that is from 0 to plus infinity, that is 1 by root 2 pi h cross from 0 to infinity, sorry, here it is up to 0, okay, root mu into e raised to, see, in the mod x, in the positive x region, it is positive, that is minus mu x into e raised to minus ikx dx. That is psi of p is equal to, here this is constant time, so I am taking it outside the integral, that is root of mu by 2 pi h cross, and now we have to take the integral of this term, that is I am taking, first of all I am writing this is in a beautiful way, that is minus infinity to 0 e raised to minus ik plus mu into x dx plus root mu by 2 pi h cross integral 0 to infinity e raised to minus ik plus mu x dx. Okay, now we can do the integration, that is root mu by 2 pi h cross integral of this term is e raised to minus ik plus mu x by minus ik plus mu plus, and this limit is minus infinity to 0 plus root mu by 2 pi h cross e raised to minus ik plus mu x by minus ik plus mu, and limit is 0 to infinity, that is equal to root mu by 2 pi h cross, and now we have to substitute these limits, and when we are substituting the upper limit, that is 0, we will get 1, that is e raised to 0 is 1 minus infinity, so e raised to minus infinity is definitely 0 divided by minus ik plus mu, plus the second type, that is root mu by 2 pi h cross into upper limit, that is when we are substituting this infinity here, it will be e raised to minus infinity, e raised to minus infinity is 0 minus lower limit, that is 0, okay, so e raised to 0 is 1 divided by minus ik plus mu, that is equal to root mu by 2 pi h cross into 1 by minus I k plus mu, and here this minus and minus will cancels, so plus 1 by I k plus mu. So we can cross multiply and expand, that is root mu by 2 pi h cross into I k plus mu plus minus I k plus mu divided by minus I k plus mu into I k plus mu. So this is equal to root mu by 2 pi h cross into, here this I k and I k will cancels, so we get 2 mu by multiplying these terms, we will get minus I into I, that is plus 1, that is k square minus I k mu plus mu I k plus mu square, right? So we will get psi of p is equal to root mu by 2 pi h cross into 2 mu by, here these terms will cancels, we get k square plus mu square. So this is the final answer. Another example problem. Wave function psi is equal to a e raised to minus c mod x plus ik0 x. Find psi of p. So here this one is not a normalized wave function. So first we have to find out what is a. Earlier I told you one trick. If there is a mod x term, then root of its coefficient will be the constant, that is root c. Okay, so we got the normalized wave function, that is psi is equal to root c e raised to minus c mod x plus I k0 x. Now we have to find out psi of p. So what we have to do? We have to do the Fourier transform of psi of x. This is psi of x, right? So that is psi of p is equal to, from definition, root 2 pi h cross integral minus infinity to infinity f of x, that is here psi of x e raised to minus ikx dx. Now we have to substitute for psi of x, that is psi of p equal to 1 by root 2 pi h cross integral minus infinity to infinity psi of x is root c raised to minus c mod x plus I k0 into this term, that is e raised to minus I kx dx. Now I can rewrite this as psi of p is equal to, here I am going to take this root c outside the integral, that is root c by 2 pi h cross into integral minus infinity to infinity e raised to minus c mod x plus, here I am taking this minus sign also, that is plus I into k0 minus k into x dx. Here see, this is a mod x and the integral is from minus infinity to plus infinity. So in the negative region, this mod x will have a negative value, and in the positive region it will have a positive value. So we have to separate this integral, that is psi of p is equal to root c by 2 pi h cross into, now minus infinity to 0. Okay, first I am taking from minus infinity to 0 e raised to minus c x mod x. So mod x value in the negative region is minus x. So this is be plus cx plus I k0 minus k into x dx plus the second type, that is from 0 to plus infinity, that is e raised to minus c. The x value in the positive region is positive, so cx plus I k0 minus k into x dx. Now we can perform this integrals, that is equal to root c by 2 pi h cross integral of this term, that is e raised to cx plus I k0 minus k x by c plus I k0 minus k, limit from minus infinity to 0, plus integral of this term is e raised to minus cx plus I k0 minus k into x by minus c plus I k0 minus k, and the limit is 0 to infinity. Now we can substitute these values, that is root c by 2 pi h cross. So first we are substituting this upper limit, that is 0. So this one will be e raised to 0 plus, okay, so that is e raised to 0 is 1 minus lower limit, that is minus infinity. So that will be e raised to minus infinity is 0 by c plus I k0 minus k, plus the second time upper limit is infinity. Here it is minus infinity, so this will be 0, and we are inverting this term as k minus k0, so there will be a minus sign. So again we got this is equal to e raised to minus infinity, so it will be 0. Okay, minus lower limit, that is 0, that is e raised to 0, here also 0, that is minus 1 by minus c plus I into k0 minus k. Okay, so this is the final result. Here what I done is, nothing is there. I changed this k0 and k, that is I took minus I into k minus k0. Okay, so there is a minus I, so into x. So when we are substituting infinity for x, so this will be minus infinity. Okay, e raised to minus infinity, that is 0. Okay, that is what I done. So this psi of p we obtained as root c by 2 pi h cross into 1 by c plus I k0 minus k minus 1 by minus c plus I k0 minus k. So we can cross multiply and simplify this, that is root c by 2 pi h cross into minus c plus I k0 minus k minus c minus I k0 minus k divided by c plus I k0 minus k into minus c plus I k0 minus k. Okay, that is equal to root c by 2 pi h cross. Here there is plus I k0 minus k and minus I k0 k. So it will cancels and we get minus 2c divided by c into minus c, that is minus c square, and I k0 minus k into I k0 minus k, that is minus k0 minus k or square, and the other terms will cancels. So the final answer will be root c by 2 pi h cross into minus and minus will cancels. So 2c by c square plus k0 minus k or square. Again you can simplify by cancelling this c and the 2. Okay, so this is the final answer. One more example problem. Psi of x is given, that is equal to a e raised to minus x square by a square, and the question is to find psi of p. Okay, here also a constant is there, that is this is not a normalized wave function. So first step you have to normalize, that is you have to find out value of a. Okay, so what is the condition for normalization? That is minus infinity to infinity mod psi square dx should be equal to 1. So that is minus infinity to infinity mod psi square, that is a square e raised to minus 2x square by a square into dx, that is equal to, we can take this a square outside, into integral minus infinity to plus infinity e raised to minus 2x square by a square dx. We already discussed some equation. I already told you the solution of this integral. What is that? That is integral minus infinity to infinity e raised to minus a x square dx is equal to root pi by a. Okay, here in this case a is equal to 2 by a. Okay, so this will be equal to a square into root pi by a, that is here a is 2 by a square, that is pi a square, right? That is equal to 1 from normalization condition, that is a square is equal to root 2 by pi a square. Therefore a is equal to 2 by pi a square all raised to 1 by 4. Okay, so we got the normalized wave function, that is psi of x equal to 2 by pi a square all raised to 1 by 4 into e raised to minus x square by a square. Now we have to use the Fourier transform and find out psi of p. That is, we know psi of p is equal to 1 by root 2 pi h cross integral minus infinity to infinity f of x, that is here psi of x e raised to minus I kx dx. Right. So we have to substitute for psi of x, that is psi of p is equal to 1 by root 2 pi h cross into, here I am taking this constant also outside, that is 2 by pi a square all raised to 1 by 4 integral minus infinity to infinity e raised to minus x square by a square into e raised to minus I kx, that is minus I kx into dx. Again, we are familiar with this integral. Here we know the value of this integral. What is it? That is minus infinity to infinity e raised to minus ax square plus bx plus c. If some integral is in this form, then its result will be root pi by a e raised to b square minus 4ac by 4a. So we can use this equation here, and here we know what is a. Here a is equal to 1 by a square, and what is b? B is ik. Okay, so by substituting these values in this equation, we can find out the solution of this integral, right? That is psi of p is equal to 1 by root 2 pi h cross into 2 by pi a square all raised to 1 by 4 into integral value is root pi by a. Here a is 1 by a square, so it is root pi a square into e raised to b square. B is ik, so square will be, so when we are taking square, it will be minus k square minus 4ac. There is no c term here. In this equation, there is no c term, so this will be 0 by 4a. A is 1 by a square, that is into 1 by a square. That is, we got psi of p is equal to 1 by root 2 pi h cross 2 by pi a square all raised to 1 by 4 into root pi a square into e raised to minus k square a square by 4. So there is some pi terms are there. You can cancel some root pi and 1 by root pi, and okay, so finally you can simplify this to a very simple form. That is a work for you. Okay, so please simplify this equation to very compact form. Okay.